Hi everyone, my name is Kanan Iyer and I'm a Senior Solutions Architect in the in-memory team at AWS. Today I'll be discussing new features of ElastiCache for Valkey 8.0. This short video is for audience who uses ElastiCache for Redis or Valkey. This presentation outlines the new features in ElastiCache 8.0. Many of these new capabilities were originally developed in earlier versions of ElastiCache and are now being made available in Valkey, the open source fork. Let me walk you through the performance improvements in Valkey 8.0 open source software. These features are based on functionality we had previously implemented in earlier versions of ElastiCache. Multi-threaded I/O was introduced to outperform single-threaded models by handling more concurrent client requests in parallel, reducing bottlenecks, improving CPU utilization, and delivering higher throughput with lower latency, especially on large instances. As a result of this feature, the multi-threaded architecture achieves a query processing capability of 1.2 million QPS or queries per second. This wasn't just about adding threads. We completely redesigned how I/O operations work. The system now intelligently distributes tasks across cores, and our command batching system optimizes memory access patterns to reduce CPU cache misses. Let's dive into the core of Valkey 8.0's I/O threading system. The picture in this slide is from Valkey.io site. I/O threads are worker threads that handle jobs from the main thread. These jobs include reading, parsing commands, writing responses, polling for I/O events, and memory deallocation. This design frees up the main thread to focus on executing commands. The key features of the main thread is the main thread orchestrates all the jobs spawned to the I/O threads, ensuring that there are no race conditions occurring. Valkey 8.0 improves performance with dynamic thread scaling, adjusting I/O threads based on load. Despite the dynamic nature of I/O threads, the main thread maintains thread affinity, ensuring that when possible, the same I/O thread will handle I/O for the same client to improve memory access locally. We have also optimized socket polling. Epoll wait calls, which are previously consuming over 20% of the main thread time, are now offloaded to I/O threads. Only one thread, either the I/O or the main thread, executes epoll wait time at any time. Lastly, we have introduced prefetch command keys procedure. This reduces external memory accesses when executing commands on the main dictionary. This significantly boosts Valkey's ability to handle concurrent operations efficiently, laying the groundwork for dramatic performance improvements. So we have done some comparison between ElastiCache Serverless 7.2 for Valkey and 8.0 for Valkey. Before we dive deeper into the ElastiCache serverless implementation, let me first clarify the technical terms listed on this slide. The first one is RPS, which is requests per second, the number of requests your system handles each second, a key measure of throughput. P50 is 50th percentile latency, also known as median latency. 50% of requests are faster than this value. P99 is 99th percentile latency, represents the slowest 1% of requests, useful for understanding tail latency and worst case user experience. These core improvements translate into remarkable real-world benefits in ElastiCache. As can be seen in the graph, ElastiCache Serverless version 8.0 for Valkey scales much faster, taking under 13 minutes to scale from 0 to a peak of 5 million requests per second, effectively doubling supported RPS every 2 minutes. The latency profile remains consistent. P50 read latency remains under 1 millisecond, and P99 latency improves to 7 to 8 milliseconds compared to the earlier version. In comparison, ElastiCache Serverless version 7.2 for Valkey takes approximately 50 minutes to scale to the peak of 5 million requests per second. We are able to add these improvements in Valkey OSS, open source software, and ElastiCache Serverless. ElastiCache Serverless can now handle faster burst scaling and faster scale-out operations. By enabling more cores on demand and optimizing I/O threading, ElastiCache Serverless can dynamically allocate additional I/O threads to support additional throughput. Furthermore, ElastiCache Serverless can allocate additional I/O threads to handle horizontal scaling, which involves migrating data to new shards. This enhanced scaling ability allows ElastiCache Serverless to handle high traffic scenarios and sudden spikes more effectively, benefiting applications that requires high throughput and minimal latency. Memory efficiency was a major focus in this release. We have fundamentally changed how we store keys by embedding them directly in the main dictionary. The picture in this slide is from Valkey.io site. This might sound technical, but think of it as removing the middleman. We no longer need separate pointers for each key. Embedding keys improves cache performance by reducing pointer dereferencing, leading to faster data access. We've noticed that there are a lot of pointer chasing in the Valkey implementation of hash table, which is a core data structure. We were able to optimize this by embedding data in flexible memory allocations, and this can save up to 8 bytes. In Valkey, a bucket is a slot in a hash table where key value pairs are stored. When a key is hashed, it determines which bucket the corresponding value will reside in. If multiple keys hash to the same bucket, a collision happens and Valkey uses a linked list to store these entries within the bucket. For example, imagine you have the following key value pairs: key 1, value 1, key 2, value 2, and key 3, value 3. If key 1 and key 2 hash to the same bucket, the bucket will contain a linked list of dictionary entries. So in this case, the bucket 0 will have key 1 value 1 pointing to key 2 value 2, which will point to null pointer. Now in future, another key value pair, let's say key 3 or key 4 value 4, is hashing to the same bucket, then the key 2 value 2 will be pointing to key 4 value 4, and which in turn will point to a null pointer. Our new per slot dictionary architecture has also eliminated a lot of overhead. For typical workloads, we are seeing memory savings of up to 10%, and in cluster configurations, we are saving 32 bytes per key. Better memory efficiency allows you to get even more out of your highly efficient cache, or if your dataset is fairly static, it provides an opportunity to cost optimize. The per slot dictionary optimization is only relevant in cluster mode, where 16,384 hash slots are distributed across nodes. Previously, Valkey used linked lists, which includes slot previous and slot next, to manage slot to key mapping, which added 16 bytes per key. By moving to one dictionary per slot, this overhead is removed. Also with Valkey 8.0, users will see a reduction of 24 bytes per element stored within the set data structure. So in the previous slide, we discussed how we improved memory efficiency with embedded keys by saving 8 bytes per key. Now 8 bytes might not seem like a lot, but a lot of caching workloads have relatively smaller keys and values. We benchmarked one customer who used on an average of 16 byte keys and values, and they saw over a 20% reduction in memory usage when they moved from Valkey 7.2 to Valkey 8.0. Now let's look at monitoring improvements. You can't improve what you can't measure. Our new observability features gives you unprecedented visibility into your cluster's performance. We're now tracking metrics at the individual slot level, which is like having a microscope for your cache performance. The beauty is that all this additional monitoring only costs you about 0.7% in terms of performance impact. That's negligible considering the insights you gain. Valkey 8.0 now provides per slot metrics via the CLI command, cluster slot stats command. This gives detailed stats for each of the 16,384 hash slots, and which includes like command counts, latencies, key movements, and cache hits and misses. Previously, metrics were only available at the node level, making it hard to detect overloaded or slow slots. With this new visibility, it's much easier to identify traffic skews, debug migration issues, and optimize rebalancing decisions. Overall, it's a big win for observability and makes monitoring tools like CloudWatch and Prometheus far more effective. The key takeaways are ElastiCache for Valkey 8.0 is a comprehensive upgrade. that touches every aspect of the system. Right out of the box, it delivers better performance, reduced operational costs, and improved overall stability. What's great is that it introduces no breaking changes, so teams can upgrade smoothly without any disruption. It's just not about immediate gains. This release also lays a foundation for future innovation. Valkey 8.0 is production ready, and the community is actively encouraged to provide feedback to help shape its ongoing evolution. For getting started on Amazon ElastiCache, please scan the QR code to access various learning resources, use cases, and prescriptive guidance. And thank you for watching this video.